Welcome to video on Bootstrap simulation in a regression, in econometrics, or in any other analysis. So today I am going to discuss how to do Bootstrap simulation. In Monte Carlo simulation, we discussed that we know the underlying probability model and we have generated errors here from standard normal distribution. But in Bootstrap simulation, we'll assume these residuals as our population. This sample of size 20 will be considered as our population, and we'll resample from this sample, and every time we'll calculate a sample of size 20 of these residuals. We'll add in sales hat, we'll have a new value of simulated sale, and we'll regress this sale simulated on advertising. Every time we'll have a new slope which we call slope simulated, and the point is that this sample of residuals will be considered as population, from which we'll keep on generating sample of size 20 again and again. With replacement, some residuals will be repeated, but slightly different values will be added in these sales, and this will lead to new values of sales simulated. Bootstrap simulation is very useful when sample size is so small, particularly when we do panel unit root testing, co-integration, or in medicine we have data on rare diseases, animals, or some other you see some other related data in social sciences, where you cannot have a large sample. So if sample size is small, critical values for one sample to another will be different. So if I have a sample of size 20, you have a sample of size 20 with slightly different values, your critical values, your underlying distribution may not be the same. So let's see how we do this Bootstrap simulation. I have already calculated this slope on by regressing sales on advertising, and intercept by regressing sales on advertising, and now we shall calculate sales estimated. This is my regression line or sales hat. Will generate residuals here. Last time we have generated here errors from standard normal distributions. Now we can take a sample of size 20 with replacement from this these original residuals, and you'll see that some of the residuals will be repeated more than once, some will be repeated missed out 0.11, 0.11. So this is here you'll find some 0.11 and it is repeated maybe 2 times, 3 times. Next time I'll do some other residuals will be repeated, and every time we'll have a new slightly different values of sales, and we'll regress this sales simulated on advertising. When I regress it again, since these values keep on changing, so slope will keep on changing. Oops. So you see every time this slope will be different, again it will be different, and you can keep on pressing F9 to generate new values. No, there are different ways to do generate this slope. But at the moment we are going to use Bootstrap add-in, basically, which is available in Excel. You can download the link, same link which I have used for Monte Carlo simulation add-in. No, this is my original sample from which I'll generate new Bootstrap residuals. I'll keep on adding in sales sim, and at the moment I am basically doing, because I have to generate residuals from this one, this slope will be more exactly same as the previous one, but no, we'll see the magic. So you see, we'll go to files, options, add-ins, go here, browse where your Bootstrap add-in is, and no, let's go add-ins. Okay, add-ins. Sorry for keeping you on waiting. So we have here Bootstrap add-ins. Yes, okay. No, I have this Bootstrap add-in here. No, I have original sample, which is my residuals, and we'll keep on taking a sample of size 20 from these residuals, and I am going to replace these residuals. So at the moment, and what the cell we have to track? The cell we have to track is your slope coefficient. If I take 1,000 or the 10,000, it will take a lot of time. So just for demonstration, I am going to use it only 100 samples, and it is asking that it will be. This is how it will proceed, and you will have now 100 slope values generated. If you do 1,000 times, 10,000 times, it will generate your slope simulated values, and it will find out, you can make its distribution. So this is how your Bootstrap simulation helps you to find out the underlying distribution for any statistics to generate critical values. Please do this practice. I hope you learn a lot. This is my sampling distribution of slope estimator, whose values from one sample to another, every time we have generated simulated values, every time we'll have a different value of slope, and now its distribution is here for 100 repetitions, which took 30 seconds. You can generate it more number of times. Thank you for watching. I hope it will help you a lot in generating simulated critical values for